Dear students, in the last class we have discussed about that Lagrange's linear equation in method of grouping. In the class we are going to discuss the Lagrange's linear equation in the method of multipliers. For this, first you have to define that what is Lagrange's linear equation. The Lagrange's linear equation is in the form of Lagrange's linear partial differential equation is capital P, small p, capital Q, small q equal to R. For this given equation, we have to write the subsidiary equation. So, to solve the equation, it is enough to solve the subsidiary equation. What is the subsidiary equation here? Dx by capital P, dy by capital Q, dz by capital R. In the method of multipliers, what is the procedure to solve? Procedure to solve in method of multipliers. So in the last class I have explained when you have to choose that Lagrange's linear equation, method of grouping and method of multipliers. So in the last class itself I explained that when that XYZ is in the format of multiplication, PQ are the functions of XYZ. So here we can see that P equal to XYQ equal to YZ and R equal to ZX. In case if you are not seeing the previous class, please you go through that and then you will be understand very easily. So here in case the functions of x, y, z is in the multiplication, then we have to go for the method of grouping. In case if it is in that addition, then we go for that method of multiplier. Okay. So this is a shortcut when you have to choose that method of grouping and method of multipliers. Okay. So what is the procedure to solve that method of multiplier is choose any three multipliers L, M, N. Choose that some other new pen. Let me take that. Because if you are taking some different color, it will be looking good. Okay. So if you choose any three multipliers, L, M, N, so which may be the constant, constants are functions of x, y, z. It is purely based on that problem only. There is no predefined to choose that LMN. That is, we have to choose that LMN based on that PQR. are functions of x, y, z. So we have dx by p, dy by q, dz by r equal to, in case if you are multiple and divide with that the same constant L, then L divided by L dx divided by LP. Then multiply with that the same constants or functions in the numerator and denominator, the value will not be varying. And then you have to do some other arithmetic operations here, that is L dx plus M dy plus N dz divided by M q plus N r. So here what are you doing? Actually, here we can see the calculation how you are doing that. That is already some subsidiary equation is there. What is the subsidiary equation here? Dx by p dy by q dz by r. Here you are doing that L divided by L, M divided by M, N divided by N. So the next step what you are doing that, adding in the numerator, adding the denominator. Then what you get? L dx plus M dy plus N dz divided by LP plus MQ plus NR. Okay, so this is the way you are get that this additional subsidiary equation. Take it this as a fourth subsidiary equations. We come here. Next step, if you are choosing that LMN, then if it is possible to choose LMN, it is possible to choose LMN to make it the denominator equal to 0. If you choose that, if it is possible to choose that LMN such that LP plus MQ NR equal to 0. So in case if you are choosing that LMN to make it this denominator equal to 0, what happen? Then it is equal to, in case if it is equal to some constant k, then the numerator value will be 0, because if you are cross multiple here, k into 0 is 0, then L dx plus M dy plus N dz equal to 0. Okay, so in the next step we will see that how we are solving that. In case if you are choosing that LMN such that LP plus MQ plus NR equal to 0, that means the denominator equal to 0, then what happened is, then L dx plus M dy plus N dz equal to 0. Case if L dx plus M dy plus N dz is an exact differential, then on integration, we get a solution we get the solution. Solution is known as that integration of this equation. So if you are integrating this, you will get that integral over L dx plus M dy plus N dz equal to some constant C1. Okay, you can take this as equation number u. Similarly, choose that some other, except already we are choosing LMN, now we are choosing some other multipliers L dash, M dash, N dash. So here also that which may be the constant, which may be constants or functions of x, y and z. So here also we can have L dash dx, same procedure, M dash dy plus N dash dz divided by L dash p plus M dash q plus N dash r. Even here also we can take that as some constant k, say. Okay, so in case if you are choosing that L dash, M dash, N dash, as you make it that to make the denominator equal to 0, according to that L dash, you have to choose that L dash, M dash, N dash. So if the denominator equal to 0, then you will get that L dash dx, M dash dy plus N dash dz equal to 0. If you are integrate on both sides, then you will get that integral over L dash dx, integral over L dash dx plus M dash dy plus N dash dz equal to some constant 2. You can take this as solution V. So in case if you are solving the Lagrange's linear equation, you will get that the general solution in the format of the form pi of u comma v equal to 0. Already we have discussed how to write that the solution pi of u comma v equal to 0 in the method of grouping. Okay, so here this LMN, the set of multiplier, and L dash, M dash, N dash are called Lagrangian multiplier. Please keep it in mind. It may come as a MCQ. L dash, LMN, L dash, M dash, N dash are called the Lagrangian multiplier. Okay, so that choosing that LMN and L dash, M dash, N dash, the two set of multipliers are totally based on that the problem. Okay, so there is no any predefined method to choose this multipliers. To make it the denominator equal to 0, you have to choose it. In case if the denominator equal to 0, then we have to solve this same Lagrange's linear equation in the method of substitution. That is the one more method is there, we will discuss in the next class. First we will discuss few problems in method of multipliers. First problem, find the general solution of problem number 1. Find the general solution of x into y square minus z square into p plus y into z square minus x square q equal to z into x square minus y square. We can write the solution for this. What is given here? Given is x into y square minus z square p plus y into z square minus x square q equal to z into x square minus y square. So what is the equation of the form? The equation of the form capital P, small p, capital Q, small q equal to R. So what is the given equation? Equation number 1, which is in the form where capital P equal to x into y square minus z square. That means if you are comparing P here, just we can write it as a, so here it is P, that in the place of P, x into y square minus z square is there. In the place of Q, y into z square minus x square is there. Okay, remaining R can easily identify that R is z into x square minus y square. So Q is y into z square minus x square, R equal to z into x square minus y square. In the engineering, this topic is that very important topic, solving that Lagrange's linear equation. Because in the mechanics, particularly mechanics field, or that in the fluid dynamics, this type of problem will come. That is in solving that streamline, in finding that path line or streak line. So this application, this type of problem, Lagrange's linear equation will come. So once you find that PQR, next you have to write that the subsidiary equations. The Lagrange's subsidiary equations. Subsidiary equation is dx by p dy by q dz by r. Substituting the PQR here, you will get that dx by x into z square minus y square minus z square, that is equal to dy divided by y into z square minus x square equal to dz divided by z into x square minus y square. We can see the denominator here. In case if you are choosing some multipliers, we can make it the denominator equal to 0. Okay, so we can write the denominator here. This is one denominator, this is one denominator, this is one denominator. In case if you are multiple with that x, y, z, what happened? That is, it is like the trial and error method. You have to choose the three set of multipliers, and then you can check it that whether the denominator is 0 or not. Okay, so first we have to choose that one set of multipliers x, y, z. In case for roughly we can use it. In case if you are choosing that x here, then what happened to denominator? Only I am writing only the denominator value, that is multiply with x here, then we will get that x square y square minus z square. In case we are multiple with y here, plus y square into z square minus x square. In case in the denominator, if we are multiple with the z here, then z square x square minus y square. Expand it, you will get that x square y square minus x square z square plus y square z square minus y square x square plus z square x square minus z square y square. Now we can see that x square y square get cancelled, x square y square get cancelled, x square z square x square z square, y square z square y square z square get cancelled. So here we will get that the denominator equal to 0 here. So this is the way you are using that the multiplier. Otherwise, in case if you are divide with that x y z, what happen? In the same denominator, that is the first case. In the case 1, if you are choosing that x y z, then what happen? In case 2, that is you have to choose the two set of multiplier, case 2. First you have to do that roughly, then you can do that the fair copy. Okay, case 2. Case 2, in case if you are choosing that 1 by x, 1 by y, 1 by z as the multiplier, as the multiplier, then what happens? That is I am doing here the rough work. Okay, 1 by x, 1 by y, 1 by z as the multiplier, then that is you have to divide with that x here in the denominator. First you have to do the denominator divided by y divided by z. What happen? That is you will get that in the denominator y square minus z square plus z square minus x square plus x square minus y square. Once again that is equal to 0. So this is the way to choose that multiplier. Now I will continue that problem here. Use Lagrange's multiplier. Use Lagrange multipliers first set of multipliers are x, y, z. In case you are writing that x, y, z as a multiplier, we will get that x dx plus y dy plus z dz divided by, as we done here, divided by x square y square minus z square plus y square, whatever the denominator is there, we have to copy here. That is y square, z square minus x square plus z square, x square minus y square. So that is equal to some constant k. What happened? Now the denominator equal to 0, you will get that x dx plus y dy plus z dz divided by 0 equal to k. So if you are cross multiple that, you will get that x dx plus y dy plus z dz equal to 0. Integrating, we get integrating on both sides, we get that integral over x dx plus integral y dy plus integral z dz equal to some constant c1. That means x square by 2 plus y square by 2 plus z square by 2 equal to, everywhere by 2 is there, therefore in constant also you can add that c1 by 2. That means that gives that x square plus y square plus z square equal to c1, which is solution u. Similarly, we have to find that one more solution v. That means if you are choosing that multipliers, use Lagrange multipliers. Use the Lagrange multipliers, 1 by x, 1 by y, 1 by z. Then we get that 1 by x dx plus 1 by y dy plus 1 by z dz. What is the denominator here? Y square minus z square plus z square minus x square plus x square minus y square. So that is equal to 1 by x dx plus 1 by y dy plus 1 by z dz divided by the denominator is 0, which is equal to some constant k. So therefore if you are cross multiple that, here you will get that 1 by x dx plus 1 by y dy plus 1 by z dz equal to 0. So integrate on both sides, we will get that log x plus log y plus log z equal to log c2. That means, which is solution b. So finally we can write that the general solution is, hence the general solution is pi of u comma v equal to 0. Therefore that we can write as f of x square plus y square plus z square comma x y z equal to 0. This is the required general solution. One problem. You can write problem number 2. Solve y square plus z square p minus xy cube plus xz equal to 0. You can write the solution for this. That is in the last problem, in case if you are choosing some multipliers, then just you can mark in that either pencil, it is like if you have put some rectangle box for this, and easily identify the example. One more set of multiplier is here is the x, y, z is the one set of multipliers. 1 by x, 1 by y, 1 by z is the one more set of multiplier. How to write the solution for this? What is the given equation you have to write? Y square plus z square into p minus xy cube. That is, you have to write that on the right hand side minus xz. So what is p here? Y square plus z square. Q is minus xy. R is minus xz. The Lagrange subsidiary equations are. So what are the Lagrange subsidiary equations? Lagrange subsidiary equations: dx by b, dy by q, dz by r. That means dx by y square plus z square, dy by minus xy, dz by minus xz. So what is the format of this? Dx by capital P, dy by capital Q, dz by capital. This is the format. So here we can see that xy in the multiplication in term 2 and term 3. Sorry, term 3, sorry, term 2 to term 3. Okay, see, x and y are the in the multiplication form. So we can choose that 2 and 3 will get that. Choose 2 and 3, that is dy by minus xy equal to dz by minus xz. So here that minus minus will get cancel, xx get cancel, then we can write that dy by y equal to dz by z. That means if you are integrate on both sides, if you are integrate on both sides, you will get that integral over dy by y equal to integral over dz by z. That means log y equal to log z plus some constant log c1. Therefore log y minus log z equal to log c. So we can write log y by z equal to log c1. That means y by z equal to c1. Y by z equal to c1, which is equation U. That is one problem. That means one solution we can get it in that method of grouping. This is the method of grouping. In case the other one solution we have to get that at the time, we have to use that the method of multiplier. In the same problem we can use that the method of grouping and method of multiplier both. So use the Lagrange's multiplier. Use the Lagrange's multiplier x, y and z. We will get that x dx plus y dy plus z dz divided by x into y square plus z square minus xy square minus xz square. That is equal to some constant k. We can see here what is the denominator, x dx plus y dy plus z dz is a numerator. What is the denominator here? Xy square plus xz square minus xy square minus xz square. So that means x dx plus y dy plus z dz divided by the denominator 0. Now if we are integrating this, we will get that x square by 2 plus y square by 2 plus z square by 2. In case we are equating to, already we are 10 here constant k na. Okay, and then you have to cross multiple that, you will get that x dx plus y dy plus z dz equal to 0. Here I am writing x dx plus y dy plus z dz z dz equal to 0. So if you are integrate on both sides, you will get that is equal to c2 by 2. So we'll get that x square plus y square plus z square equal to c2, which is that solution V. So what is the general solution here? Hence the general solution is general solution is f of u comma v equal to 0 or pi of u comma v equal to 0. Therefore you will get that a function of y by z comma x square plus y square plus z square equal to 0. So here f is the arbitrary function. Here I am giving one or two problems for the practice. First problem, solve three z minus 4y p plus 4x minus 2zq equal to 2y minus 3x. The answer for this problem, phi of x square plus y square plus z square comma 2x plus 3y plus 4z equal to 0. That is our first problem. Second problem is x into y minus z into p. Solve x into y minus z into p plus y into z minus x to q equal to z into x minus y. The answer for this problem is y of x plus y plus z, comma xyz equal to 0. That is the second problem. Third problem. Solve x into y square plus z into p plus y into x square plus z q equal to z into x square minus y square. The answer for the problem is f of xz by y comma x square minus y square minus 2z equal to 0. In the next class, we will solve that few more problems in method of multipliers and then substitution method. Thank you.